Greetings, everyone. My name is Stephen Feuerstein. I'm an architect for Oracle Corporation, and my focus is on applied PLSQL. You can see at the bottom of the page my email address. Feel free to follow up after this conversation, after this webcast. If you have any questions or comments for me. This is the first of a 6-month series of webcasts on PLSQL. The first 3, hosted by Oracle, are on best practice PLSQL, and the next 3 are hosted by ODTUG, Oracle Developer Tools User Group, and we'll focus on high performance features. All my webinars are being recorded. They will be available on YouTube or through some other format, and we will let you know how to get that information when they're posted. And you can certainly stay tuned by following me on Twitter, SF on PLSQL, and my blog, Stephen Feuerstein on PLSQL.blogspot.com. And yes, I should have written those in on this page, and I'll write them down for you later. So, in my first webcast for Oracle Corporation, I just rejoined after a 22-year absence. It's very exciting. My first webcast is going to focus on when and how to write SQL in Oracle PLSQL. Now, if you have questions, feel free to use the chat box in the WebEx interface. I'll take questions largely when I'm done if we have time. And of course, we can have conversations after that online as much as you'd like. Okay, so when and how to write SQL in Oracle PLSQL. And I bet a lot of people are thinking to themselves, do we really need to talk about SQL? It's something that we just do. So I thought we would start this conversation by considering the typical and often silent conversations we have about SQL. And what I mean by often silent is that, I don't know about you, but as I'm writing my code or doing anything in my world, I often have a running conversation with myself. And there can be many voices going on there. Hopefully that doesn't mean anything seriously bad for me. And so we will say things to ourselves as we're writing code. So what do we say about SQL? Oh, it's so easy to write SQL in PLSQL. PLSQL is tightly integrated with the SQL language. You can write SQL statements natively. It's not even something we have to worry about. In other words, and I'll focus more on this later, SQL is taken for granted by PLSQL developers. How about no one else will ever need to write a SQL statement like this? I'm writing a new program. There's a specific requirement. I have to join with this table, that table, the other table. It always seems like what I'm doing is very specific and is not going to be needed by anyone else ever. In other words, exceptionalism. We always think that what we're doing is special and different and new, when in fact, if you've been around the block, the software block for more than a few years, you realize that we mostly do the same things or variations on the same things over and over and over again. Aha, here's a good one. Oracle will optimize it all for me automatically. I don't have to worry about how I write my SQL statements. Oracle's going to take care of it for me. And you know, Oracle does a lot for us. The Oracle cost-based optimizer is extremely powerful, and it will optimize a lot of your SQL for you. But if you really think you don't have to pay attention to how you write your SQL, you are drinking the Kool-Aid, because Oracle can't do it all for you. Finally, oh, this insert statement will never raise a dupe val on index error. Now, I don't know about you, but I need to write a lot of SQL in my PLSQL apps. Well, of course we do. And many times, those SQL statements could raise errors. So what I really should do is have a very thoroughgoing exception handling strategy for my DML statements, and I should make sure I'm logging errors and so on and so forth. But you know what I do instead is rationalize my laziness. I say to myself, well, I'm going to do an insert here, but I don't have to worry about an error occurring like a dupe val on index error because we've got a primary key. It's never going to be duplicated, no problem, or null column value errors. In other words, we try to get out of, and this is not specific to SQL, doing the right thing by figuring out a way to rationalize that we already did it, more or less. So I think these are some of the conversations we have about SQL. Let's drill in. Now, if we take a little bit of a step back, it's pretty clear to any of us who have been around the Oracle database and around database-centric applications for years that the database itself, oops, sorry, let's turn my pen back on. The database itself and the SQL language around the database is the most critical part of an application. And I say this, wow, sorry, my mouse is going crazy. The SQL statements that we write directly reflect our business models. And those models are always changing. Plus, there's the data. There's the data and more data. All of this essentially defines our business and defines our business requirements. In addition to that, the SQL statements in our application cause most of the significant performance problems. I mean, we definitely need to tune PLSQL, and I'll give you 3 webinars coming up on those topics. But tuning SQL, making sure that your SQL is optimized, that your database is optimized, overwhelms all other considerations relating to PLSQL on higher levels in the stack. And then, of course, there are many runtime errors in applications that result from integrity errors, check constraints on tables, all sorts of things. The bottom line is that SQL statements, in other words, the underlying database and the data, have an incredibly large impact on the quality of our applications, how well they can be maintained, and so on. Now, this is particularly interesting because in the last several years, there's been, as you know, a whole movement to put the word "no" in front of one of the most important and powerful enabling technologies of the modern internet era, which is SQL and relational database technology. It couldn't have happened without us, or at least it didn't happen without us. But there's been a movement away from SQL for a number of different reasons, and certainly there are a lot. The focus now is on building apps, churning out apps really fast, and so the application developer, often writing in open source JavaScript and so on, tend to devalue SQL and devalue the database because they're focusing on user-facing requirements. That doesn't mean they're right, but it does mean we have our work cut out for us. We need to start promoting these technologies and making sure people understand everything they can do with them. And of course, for a PLSQL developer, that also means that you need to make sure you're using SQL properly and to the max. So let's get back to that point of we take SQL for granted. In my experience, when people are writing applications in PLSQL, we just write SQL statements whenever and wherever we need them, over and over and over again. We don't set rules on how, when, and where SQL statements should be written. Now, ask yourself this question, because I've done so at many, many different presentations, and the answer is pretty much always the same. Let's say I've got 200 people in a room. We've got a couple hundred people on this call, maybe more now. And I'll ask people to put up their hands if they have coding standards. Who has coding standards on PLSQL? And out of the 200, maybe 50 hands are raised. So naming conventions, standards for this, standards for that. Great, that's good. Then the next question is, how many of you have inside those coding standards anything about how, when, and where to write SQL? And generally, almost every hand goes down, and we're left with a handful, 2, 3, 5 hands out of 200. 5 out of 200 people work in organizations in which they've actually discussed and made decisions about how to write SQL in their applications. That's pretty crazy. And it's an example of how we as developers have taken SQL for granted and just assume the right thing will happen all the time. And that taking for granted extends out even wider to Oracle, not making sure that we provide you with some of these guidances and details on how best to write SQL. So we take it for granted, we write it wherever we want. And then there's another problem. We don't stay current. So it's very difficult to keep up with all the great new stuff that Oracle puts into the SQL language. And as a result, we end up using old versions essentially of SQL. I might be on Oracle 12, but I'm writing SQL like I'm on Oracle 9. And perhaps even worse, we fall back into PLSQL or Java or JavaScript when the going gets tough. When I can't figure out how to do it in SQL, I say, well, I'll just fill in my gaps of knowledge with PLSQL. So going back to this first point for just a moment, let's take a look at the diagram to the right. So we've got the back end. That's the enormous chunk of black box for most application developers, especially JavaScript developers. Oh, it's just this big black box of reading and writing rows, and who cares about it? We know, of course, that there's a lot more to it. So at the bottom of the back end, of course, has multiple layers itself. We have our tables, our relational tables. And then we need to write application code to interact with those tables. And the problem is that most application developers, whenever they need to get information, they'll write a select statement right inside their high-level application code. And if they need to make any changes, they execute DML statements against the tables directly from inside their high-level application code. So we have a proliferation of SQL statements all over our application. And the result? Slow, buggy code that is hard to optimize and maintain. Let me emphasize this. If you don't have standards for how you write SQL statements and everybody does their own thing all the time, then you've essentially lost control of your application. And it's very difficult to find all the places that need to be optimized, to find all the places that need to be updated when we identify a bug, and so forth. So you take it for granted, you don't pay attention to it, you don't have standards, you kind of end up with a mess. And if we're ending up with a mess, just think about the folks out there who are not trained in this relational technology. Now, of course, when I say we have a mess, I'm not saying that all of our applications are failures. In fact, our applications are wildly successful around the world. Oracle-based, PLSQL-based applications run the world, essentially. So many critical applications. But we know, of course, that there's a difference between what we show our users and what they experience, and on the other side, what our code looks like and how difficult it is to maintain it over time. And that's where things get really messy. And we pay a price long term. And of course, our users pay a price at every term because it is difficult to meet the requirements and make it go fast enough, and so on and so forth. So my suggestion is that the next time you're about to start a new project, you ask yourselves two key questions related to SQL. Number one, are we taking full advantage of the SQL language? Do we know about the new features in our latest version? Because we should definitely do as much as possible in what you call pure SQL. Pack everything you can in a native SQL statement. Number two, do we want standards? So I'm not even asking you to ask the question, what should our standards be? I just want you to ask yourselves in a group, sitting around a table, look at each other and say, do we want standards, or should we just keep on doing whatever the heck we've been doing? And you guys might decide, no, we're going to keep doing what we've been doing. It works okay. Fine. At least you made a conscious decision. But I'm really hoping that the answer will be, oh my gosh, of course we want standards. Let's figure out what some standards should be. Now, in the next 45 minutes, I'm not going to be able to present to you comprehensive standards and best practices for everything having to do with writing SQL and PLSQL. Number one, it's not possible. There's just too much. Number two, I don't want to get lost in the details. In fact, to make sure we don't get lost in the details, let's go back. Then we'll go into those details. I think the most important aspects of learning how to use SQL properly in a PLSQL application is to understand some high-level principles that guide what you do. And it turns out those high-level principles are really no different from other high-level best practice principles, really revolving around one single core concept, which is never to repeat anything. And I'll come back to that and explore it. But I do want to just set the expectation that we're not going to go through 25 different detailed coding recommendations in this webinar anyway. Okay, so number one, you definitely have to fully leverage SQL in your PLSQL code. Now, PLSQL has been enhanced with every new version of the Oracle database, but the rate of change in PLSQL is fairly mild compared to SQL. Oracle continually adds significant new functionality in every version of the database to the SQL language. And if you don't keep up with those capabilities, you'll end up writing slower, more complicated PLSQL code than is necessary. Now, we all know that when Oracle comes out with a brand new version like 12.1, everybody's not jumping to upgrade their database to that version. The database is too critical. You have to take your time and make sure it's solid and make sure you've got a plan in place and so on. So I know that for many developers, when the 12c docket is released, not a lot of attention is paid to it. But I think you need to change your perspective on that. So first of all, I know that I'm pretty widely admired as a PLSQL developer, but I have to tell you that I am a good example of what you don't want to be as an all-around Oracle application developer, because I have not kept up with SQL. Maybe now that I'm inside Oracle, I'll have to. But I've been focusing so much on PLSQL, I haven't kept up with the great new features of SQL. And so I, in fact, do fall back into PLSQL when things get tough, and I pay a price in my software. You shouldn't do the same thing, and you probably can't afford to do the same thing. And just one little point before I move on, and we're not going to be able to talk about it more today, but one of the great ways to escape from SQL is you have to write some really heavy-duty procedural code to generate a data set to be used inside an SQL statement. You might take a look at table functions. And I'll definitely do a webcast on those in the future. But they're a really neat feature in which you can select from a function as if it were a relational table. Good stuff. Okay, so if you don't keep up with SQL, you're going to end up writing unnecessarily complicated PLSQL code that runs more slowly than it should. So take the time to refresh your understanding of the SQL language. You should be all on 11G right now. And so what you should do with each new release of Oracle, and certainly the current one you're on if you haven't done this yet, is go check out the new features list in the docs. All the Oracle documentation is online. And you can go to the new features list for the SQL language reference and look through the list. See if anything stands out immediately as something that you could say, oh my gosh, that will make an enormous difference in program X. And then start to explore how to define it, how to add it. For new versions, like Oracle Database 12c, which you're probably not going to be using for a year or 2 years, who knows, look through that list of features nonetheless and ask yourself, if this is a feature I want to be using, what do I need to do to prepare for it? A good example of this is the function result path, which I may be able to touch on a little bit later. And in fact, I'll be doing a webinar on in 3 more months, the first of my performance webinars. The result cache is a fantastic feature added in 11.1 of the database. And even if you weren't on 11.1, you wouldn't be there for several years. That feature really called on you to start doing things differently in the way that you wrote SQL. And I'll come back to that when we talk about encapsulating SQL statements. Okay, finally, I do encourage you to check Tom Kite's resources on OTN and Ask Tom. Tom is like me. Sorry, I want to be like Tom when I grow up. Tom is excellent at PLSQL. He's excellent at SQL. He's excellent at Oracle database architecture, everything. So he goes broad and deep, has an enormous amount of resources for you, and I encourage you to check him out. So fully leverage SQL. Just to give you a sense of the kind of things you can do in case you haven't been paying attention. None of this is actually on 12.1. This is all 11 and lower. So there are now analytic functions such as lag and lead and ranking utilities that allow you to look at previous and following rows to calculate differences between rows and do all sorts of amazing things. If you are not comfortable with or have not heard about analytical functions, I suggest that that be one of the places that you start when you refresh your knowledge on SQL. With clause. So one of the complaints people have had about SQL over the years is that set-oriented declarative programming is really powerful, but you can end up with these enormous SQL statements that go on for multiple pages, might even have whole blocks of repeated SQL code because you can't have named code fragments inside SQL statements and so on. Well, now you can. So with the with clause, you can actually create essentially virtual tables inside your SQL statement. And then you can reference them by name in multiple places throughout that same statement. You can essentially normalize your SQL content and create them as essentially subqueries. In addition, in 12.1, you can say with function, and you can define a function directly inside a query, which offers some interesting performance improvements. Flashback query, there's no need for journaling tables, audits, history tables, etc. New ANSI join syntax that replaces the old plus operator. And hopefully you should use that and it's more readable. I'm still stuck on my plus operator when I do outer joins. What can I say? Enhancements to hierarchical queries and then scalar subqueries. So essentially, any place you can use a single value expression like select x comma y, you can put in a select statement. And as long as that select statement returns a single value, off you go. Really nice stuff. This is just a tiny fraction of all the new things that Oracle has added to SQL. So again, I encourage you to go exploring. If you have a team of, let's say, 5 people, 3, 5, 10 people, have one person assign the task of analyzing new features and coming up with a recommendation about what should be used or what should be anticipated to be used. Same thing, of course, with PLSQL. Okay, so yes, leverage SQL fully. We're done with that. Now let's focus more on the PLSQL side of things. So do we want standards for writing SQL? And hopefully you say, yes, 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 yes. Without standards, you can't take full advantage of this technology. You will not be as successful as you could be. Now, I'm going to focus on a small number of what I consider to be key best practices in this talk, but you can find many, many more in detailed recommendations from Bryn Llewellyn, who is the PLSQL product manager. Just do a search on doing SQL from PLSQL, best and worst practices, and you'll find a PowerPoint and also a PDF of that information. So that's the place to go to take my few nuggets of suggestions in this presentation and really have them fleshed out fully and use that as a basis for setting up your own standards. That would be my key recommendation right now. Okay, now before I dive into my small number of most important best practices, I'm going to take on a big challenge. Every SQL statement you write is a hard coding, and in fact, the worst kind of hard coding in your applications. Now, if you've heard me do this talk before, you won't be shocked, but I bet that if you haven't heard me do this talk, you're thinking to yourself, seriously? SQL statements are hard coding? How can that be? Now, we all know about hard codings, right? Literals are the most common example of hard coding. Let's take a look. Hopefully you can see all this code just fine. Now, if you were looking at a piece of code and I asked you, find all the hard codings, your eyes would immediately go to the literal values, often color-coded, making it easier to find. And you would be right. Those are all hard codings. But those are the most obvious and least subtle of the hard codings and the least dangerous too. So to better understand why I would say SQL is a hard coding, let's examine what it means to be a hard coding and why hard coding is bad. So I would expect that if any of you looked at this piece of code, you would say, oh, what an amateur. Everybody knows you shouldn't hard code a literal inside a piece of code like that and do it in 1, 2, 25 places, because those kinds of values are always going to change. In fact, if you ever find yourself saying, this is never going to change, just remind yourself, you're putting a bug in your code right there because of course, everything's going to change. So we can look at code like this and say, oh, what an amateur. You shouldn't do stuff like that. You should replace it with a named constant, because if you'd otherwise have to find all the occurrences and change them. Now, if you've got a value like 45098 or 1505000, you could probably actually do a global search and replace across all your files and upgrade your code to the new literal. Exciting and very scary. I don't know if any of you have ever done a global search and replace in your files, but you need to look at all the changes that were made afterwards to make sure they make sense. I once did a global search and replace and corrupted 3 days of production data. It had to be rolled back. Ooh, that was nasty. Fortunately, no one blamed me. It was so great. It was my bug. No one blamed me. They blamed the testing organization for not having found the problem. Yes, that's why I like testing organizations, to be my buffer. Okay, so we all agree that these literals are bad news. Okay, let's take a look at SQL. So my question for you is, in what way is this statement different from this literal? I write my select statement here. I write it again over here. I write it again over here. Now, I mentioned earlier that we all have this exceptionalist attitude to our code, that everything we're doing is brand new and unique and nobody's ever done it before. But hopefully when you hear me say that, you say to yourself, that doesn't sound right. Of course we repeat things. And there might actually be a 16-way join that is never repeated, but take your common single row fetches. Those are things that are repeated very often throughout our code and can lead to problems later on, and I'll come back to that. But the bottom line is that if I write this statement directly in my application code and then I write it in multiple places, no matter how complex or simple it is, when an underlying table changes or a relationship changes, you have to find all the SQL statements that are affected and upgrade them to the new approach. So what I just described to you was exactly the same process as dealing with a change to a literal value. And we can change that literal value relatively easily, find them and change them relatively easily. But when you're hard coding as a DML statement, you've got a big problem. How are you sure that you found all the same logical occurrences? It's not easy to do, and even with the tools that Oracle provides to analyze dependencies, it just doesn't get you that far. It doesn't get you that close. As far as I can tell, from a logical standpoint, a SQL statement and a literal value are the same when it comes to hard coding. So if you don't like hard-coded literals, you should hate hard-coded SQL. And I'm trying to go slow and really drive this point home, partly because we live and thrive on logic. We programmers, the rest of the world out there, not so much. But we rely on logical thinking to get our job done. So I would like to think that when I can make a logical argument that says that this and this are the same sort of thing, you should be able to accept that. You should say, wow, if it's logically true, it's true. What should I do about it? Okay, what should you do about it? Well, just one final point about this idea of it being hard coding, again, just to drive that point home, and then we'll go on to what we can do about it. Writing SQL is all about defining the now. In other words, if I'm writing a 16-way join with this complex word clause that goes on for 2 pages, no matter what I'm writing, all I'm really saying is, at this moment in time, here's how to capture that relationship or that business rule. But as I'm sure you know, our ERDs, our business models, are extremely complex and are changing all the time, usually getting more and more complex. So whatever we think the now is, whatever we think correctly represents a given requirement or a given business entity today, there's no way it's going to be that way tomorrow or a week from now. And we've got to absorb that acceptance of the volatility of our environment fully before we can really start to understand the importance of making some changes in the way we write our code. Okay, so what do we do about SQL hard coding? I know you're all convinced. Great. In fact, I realize that probably relatively few of you are convinced, and I don't get very far with that argument, but I keep on trying because it's so important. This is the most important aspect of writing high-quality code in PLSQL. So what do we do about hard coding? Well, you do have to write SQL statements if you're working against the Oracle database. And we do want to use the Oracle database. Very, very important. It is the best, the fastest, the most robust relational database technology out there. But the question becomes, where should you put the statements? Where should you put your SQL? And we can isolate this into a single don't, really. Don't put your SQL in Java or .NET or JavaScript or any of those front-end languages. The problem with doing that is that people who write that code are very rarely good at SQL. Worse than that, they don't even like SQL. They don't appreciate it. They're mostly object-oriented in their approach. They don't have experience with set-oriented thinking, which is incredibly powerful, perhaps more powerful than object orientation in many ways. So the chance that they're going to utilize the Oracle database in SQL properly is very slim. So what they end up doing is using the Oracle database as a data store. Write a row, get a row, change a row. And you can do that. You can use Oracle or any database for that. But then you're pushing more and more complexity into your front-end code. And that's not a good idea, because if we take a look at the last 20 years and the next 10 years ahead, and we ask, how often did people change their database technology compared to how often did people change their front-end user interface technology? I think it's pretty clear. The front-end languages change much more rapidly and are much more likely to change than the database. So move the SQL statements into the database, which means hide complex queries behind views and use those views in reports. Put all your other SQL statements, especially non-query DML, in PLSQL packages. Essentially, build an application programmatic interface to your underlying data structures. And if you take this approach, you're essentially going to put as much as possible of your SQL statements inside PLSQL. You'll still write queries in various front-end environments, for example, in Application Express, when you want to build a table or a report, a form, and so on and so forth. But for many developers, they hide all their tables behind views, or at least complex, common where clause combinations and joins behind views, so they can write simple selects against those views. Generally speaking, the principle is the same. Hide complexity behind something else, give it a name, and then access that thing by name. Okay. So let's drill in deeper on this idea of hiding SQL statements behind a PLSQL API. First of all, I think it's a matter of changing how you think about SQL. You should think about SQL as something not that you write over and over again, but as a service that's provided to you. In other words, I need to get all the rows from this table for a given foreign key value. Get it for me. Don't make me write it, just do it. And if you do write it, well, okay, then put it somewhere so that it can be easily found and reused by you and other people and easily maintained over time. Now, this service, this SQL as a service, consists of views and programs defined in a separate data access layer. And that intermediate, or what I would call an intercept layer, offers tremendous benefits. So I showed you the picture before about how from the application code down to the tables, people would just write their queries to get the data, write their DML statement to change the data over and over again from their application code to their table directly, resulting in a pretty big mess. Here's my suggestion instead. Between your application code and your order and your underlying tables, put in an intermediate layer. That intermediate layer is your API. And again, it can consist of packages as well as views. And then that intermediate layer knows all about the underlying tables, how to insert, how to update, delete, query. It also knows about relationships between the tables. So if I need to, for example, add a new order to my system, it's not just doing an insert into the order table. We're doing an insert here, updates here, maybe deletes here. It's a complex transaction. The intermediate layer should know all about those transactions and code them so that individual developers don't have to know about the details of the transaction and certainly don't have to write them. And then the application code, the high-level application code, should never drop down directly to the tables. You always go through the interception or the intermediate layer to do your work. You make a call to a program or a function. You do a query against a view. And then all the underlying details are hidden away. So that's the basic idea. Hopefully a number of you are doing this already. Let's take a look at the benefits. And then finally, I will show you some code. So with the data access layer in place, with that interception layer in place, first of all, the most important benefit is that I can change the implementation of my SQL with minimal impact on application code. So ideally, if we add a new column to a table, we don't want to have to go to 25 different places to add that column. If we change a foreign key, if we change a business rule, we don't want to go to 25 different places or hope we found all 25 places where we need to make the change. The reason we will need to do this, we will need to change our implementation, came from multiple causes. Number one, our underlying data structures change. That's certainly something we can depend on. We know that Oracle is going to add new features, and we want to be able to take advantage of them in a rather smooth, rapid process, and also an expensive process. And we learn new ways to take advantage of PLSQL and SQL, in other words, new features in PL/SQL language that have us thinking about changing the way we might access the underlying layer. So that's one big advantage. Minimal impact on application code as you change the underlying data model. Second, improve my SQL-related error handling. Remember I talked about how we rationalize laziness. I really should, trap for an error here and make sure I log it and find out what went wrong, but it's not going to go wrong. There's not going to be a problem. But if I'm, and it's very difficult to justify taking the time to, quote, do it right, unquote, if I'm writing that insert statement 25 times in 25 different places. If I write it one time, put it inside a procedure, and always call the procedure to do an insert, among other things, I'll feel like I have the time to do it right and to put in some much more solid error handling. And finally, one of my favorite benefits of an API for a data access layer is improving my productivity. I don't know about you, but I write a lot of PL/SQL code and I love it. But I'd really rather not spend my time writing code that I don't need to write. And to write a select statement over and over again when I wrote it yesterday and the day before doesn't make any sense to me. And copying, pasting makes even less sense. So what I want to do is reduce the amount of time I'm writing repetitive stuff and unnecessary stuff to spend as much time as possible focusing on my business requirements. Okay, let's take a look at some code. Now, this PowerPoint has a number of references to files in it, and I'll give you the link at the end of this talk as to where you can find all of this stuff. Let's go over to SQL Developer, and let's open up my 11G emp lookup. Now, I'm getting there. So you might want to make a note in your notes, because I don't have the right file reference here. It's 11G FRC encapsulation. Let's go back to the PowerPoint. So 11G FRC encapsulation. I'll fix the PowerPoint before we post it. Okay, so here's an example of what I would consider to be high-level application code. Do stuff with the employee. Pass me employee ID. Notice very nicely defined with % type. I get all the information for that employee. I drop it into a local record, and then I do some stuff. And then later on, I execute the same SQL statement, but for a different ID, the manager ID, and I get the manager information and do more stuff. So here's an example of repeating the same SQL statement right inside this one procedure, and this is a classic example of the kind of select statements you'll see over and over and over again in PL/SQL code. And you might say to yourself, Stephen, what's the problem? So if I add 5 new columns to the employees table, will I have to change this code? And the answer is no. The way I designed this code is quite resilient to change. I've got a % row type declaration so that if the employees table changes, this code is recompiled automatically or is invalidated and will need to be recompiled and get the new structure of the row. I do a select star. I don't specify the individual columns so that I will get all the columns if that changes as well. So this code is actually pretty resilient to change. That's not the problem. Is that I'm repeating the SQL statement, and over time, I might want to take advantage of new features in SQL to improve performance of these kinds of queries. Now, my approach is not to write code like this. My approach is we'll call it the employees SQL package. Usually I just call it employees manager and put all my table related stuff in there and transaction related stuff into that one package. I have a function called oneRow. Pass in the primary key, get the row, and return it. So with this function in place, when I'm writing a new program, do stuff with employee, I simply call my function twice. So employees equal one row, get the one row, employees equal one row, get the one row, and I don't repeat the select statement over and over again. Now hopefully you can see that I'm spending a lot less time writing code doing this than writing this, so there should be a boost in productivity, and every little boost helps. For queries, putting in exception handling is not that critical, but for DML statements, for inserts, updates, deletes, it is much more important, and I can again do it in this one place, and then it comes into play every time it's called. So that's an example of using the encapsulation layer to hide the SQL statement. But again, you're probably saying to yourself, you know, it's just easy to write the single select statement. I'm not going to have to worry about it changing. Why would I go to all this trouble? Well, let's take a look at a new feature called the 11G function result cast. Oops, something's wrong. G. So in Oracle 11.1, Oracle Database 11.1, Oracle added a new feature called result cache. And the result cache basically allows you to avoid requerying the same row over and over again. And not just for you as an individual session, but for all the sessions connected to an instance. It's a really powerful caching technique that can improve performance of queries quite dramatically. Now, the cool thing about the function result cache is that all you have to do, assuming you've gone through the process of setting it up with your DBA correctly, you've identified the queries and functions that you want to result cache, is you put this one keyword, result cache, in the function header and in the function body. And that's it. What then happens is that every time anybody in the database calls this function and passes an employee ID, Oracle asks, did somebody already call that function for employee ID 100? If not, execute the query, return the record. And remember that record along with this employee ID. And the next time anybody asks for information for employee ID 100, Oracle does not execute the body of the function. It simply goes to the cache and returns the record that it had stored there from before. Very powerful, very elegant feature. And if you take the time to put your queries inside functions now, like this, and it's not a big effort to take that code out and move it inside a function. If you make that effort now, or you already have done, then in an instant, you can add the result cache keyword. Here we go. I'm going to upgrade the performance of my application. This is oversimplifying things a little bit, but from the PLSQL standpoint, I'm done. I could add that one keyword and I'm done. The alternative is saying, oh my gosh, I've got 25 different queries and 25 programs. I'm going to pull them out. I'm going to put in the function call. I'll make the function result cache function. You can do that. The problem is that it's pretty expensive to change 75 programs in production. In this case, I would be changing just one. Okay, hopefully that gave you a sense of the power of encapsulation. I don't want to use up my whole time on that, so I'm going to keep on going. But I have found that building a data access layer is absolutely key to improving productivity and improving quality of your application. In fact, let me show you one more example before I move on. And it's actually this plus another. So let's take a look at an example of hiding the SQL behind a function. It's similar to what you just saw. I'm taking the employee ID here and getting the full name. In this case, I've got several different hard codings. My SQL statement is hard-coded. My variable name length is hard-coded. And my business rule is hard-coded. Awful, awful stuff. And it's the sort of thing we see in our applications all the time. And I say awful because if the formula changes, we have to change the code here. If the maximum size of a person's full name changes, we have to change this here. And I've already talked about the problems with repeating SQL. The solution is pretty simple. Here's my package. I declare a subtype, which basically gives a name to my underlying varchar key size. I declare a function that returns the full name. There's the reference to the use of the full name. And I can even have multiple overloadings depending on the inputs. And then I go back to my original code. I declare my name to be of type full name T, and my last name is generated, my full name is generated just by a function call. And now I've hidden my formula in one place inside the package body. So again, that's an example of the flow of moving from a hard-coded approach to an approach in which you're hiding the details behind the package interface. So data access layer tips and batches. So first of all, give yourself the space to do it right. And by that space, I mean mental space in your head. We often feel so hurried and pressured to get things done fast. It doesn't really take all that much time to move a query to a function or move an insert to a procedure, and then put in a call to that function or procedure. And once your package has been created, adding to an existing package is even easier. The main issue is patience and discipline. Try to tell yourself to slow down, get it right, or at least righter the first time, and the benefits downstream will multiply. Now, Tom Kite strongly recommends transaction APIs. In other words, you call the program to insert the order, and the order is a business entity. It's a transaction in and of itself, and so you build a procedure around that transaction. I agree with that completely. I also find that table APIs, individual procedures and functions to simply operate on an individual table, one or more rows in that table, can also be very helpful when used correctly. But you have to watch out for the following. Don't end up with calling a cascade of functions one after another when you can execute a single query instead. Here's what I mean. So I'm working with my HR table, HR application. I've got employees, I've got departments. I've got a procedure that takes the employee ID. I've got a function that gets me one employee. So I get the employee, and then I need to get the department information too. So I take the department ID from the employee record, and I call another function to get that one row. Now, one row lookups in Oracle are very, very fast. And unless you're working in an application environment in which every microsecond counts, you're probably never going to have to worry about this code. But it's a bad sign, because one select statement can bring me all of this information together instead of two select statements and two different round trips to the SQL engine. But because I have my functions in place, it's faster for me to do this than to write that join SQL statement. What I should do is write that SQL statement, so write the join, and then put it in its own function, in a new function, adding it to my ever-growing API of SQL encapsulation. And a final tip, generate as much code as you can to ensure consistency. And I won't get into tools for doing this. Actually, there aren't too many of them out there right now, but I'm hoping to, in the next year, resurrect at least one of mine. SQL Developer does generate some table API content. If you go to a table, and hopefully I'm still connected, and then right-click under Table, you can generate a table API, and it will generate insert, update, and delete procedures. Okay. One final, what I'm going to do is keep going through the rest of my talk, and then if I have some time, I'll show you one other example of the complexity of doing non-query BML, why you should not do an insert directly in your code, but instead hide it behind a procedure. It's a variation on the same theme, so let's make sure I capture my other themes first. Let's take a look at a few other recommendations for writing SQL in PLSQL. First of all, when fetching a single row, use select into a single row fetch, an implicit query, and of course, put it inside a function. You can also do it with execute immediate into, in other words, a dynamic single row select. And by that, what I'm implying is that you should not use explicit cursors, use implicit queries. Second, when fetching and changing multiple rows, use the bulk processing features. So if you have a query that's retrieving 10 million rows or 10,000 rows, and then you need to execute a DML operation in each one of those, you should use bulk collect and for all to get a truly incredible boost in performance. And that will be the focus of my second webinar in the performance section. So that's in 5 months from now, or 4 months from now. So sign up for that, and I'll go over that in much more detail as well. And finally, a few tips for dynamic SQL, because we're writing more and more of that in our new internet-based environment that is so dynamic and driven by our users. Bind rather than concatenate whenever possible. Always execute immediate a variable, so when things go wrong, you can figure out what the heck went wrong. And if you're executing dynamic DDL, like create table, create index, create procedure, make it an autonomous transaction. Okay, always use select into for single row fetches. I like to point this out because it has so many good lessons in it. A long, long time ago, I and many other Oracle experts, and this is back in, I guess, Oracle 6 days maybe, wow, Oracle 7. We urged everyone when you're doing a single row fetch to do a cursor declaration and then open the cursor, fetch into a record, and close the cursor, because it was faster than a select into. And for a short period of time, it probably was faster. But I believe as of 7.3 and beyond, ever since then, a single row fetch with a select into is going to be 15–20% faster than an explicit cursor declaration, open, fetch, and close. What's interesting is that the reason I like to point this out, I think everybody is well attuned to doing select into, they're also a lot simpler to write, is that you have to be aware of people making recommendations or giving you advice that's based on experiences from a long time ago. For example, if you ever try to do something, use a feature in PLSQL and your DBA says, no, you can't use that because a long time ago there was a bug, the obvious rejoinder should be, well, is it still a bug? Really, I can't use this, and test it out and make sure that it is okay. So we said a long time ago that you should always use explicit cursors. Things like that live on and on and on, especially in the world of the internet, where you can always find a link back to something from the past. It's hard to differentiate good and bad advice. So it's always good to verify things for yourself, and especially if anybody's talking about something that they experienced a long time ago, to make sure that you update the reference. So select into and execute immediate into, they perform better. They more accurately tell the story. In other words, I want to get a single row. If I don't get a single row, I will raise an error. Those errors tell you when reality doesn't fit the story. The reason I want to mention this, more accurately tells the story, is another way that people get around doing the select into and having to declare a record and da-da-da-da-da, is they do a cursor for loop, fetching a single row. You can do it. It's not going to kill anything, and it will be fast enough. It'll be performant. But for somebody to read that code, it'll be very confusing. There's a cursor loop here, so I must be doing more than one, but the where clause says for employee ID. That doesn't make any sense. When you write code, you should write code that answers questions, doesn't raise questions in the minds of somebody who's looking at your code. Moving on. Bind rather than concatenate with dynamic SQL. So with dynamic SQL, you're constructing a SQL statement on the fly because at compile time, you didn't have all the information you needed. And there's often some amount of concatenation involved, but you have to be very careful about concatenation. Because when you concatenate, you create a new physically different SQL statement, which will cause additional parsing. It's more vulnerable to SQL injection. You can inject through concatenation, not through bind variables, and it's much harder to read and maintain. So you should bind all variables as much as possible. In fact, you should restructure your dynamic SQL to use bind variables as much as possible. And then you'll increase the chance of reusing the parsed statement. Injection will not be a problem, and it'll be much easier to read. Let's take a look at an example. Here's a program that is a very kind of dumb update statement. It basically says for any numeric column in your table, give me the start and end dates and the value, and I'll update that column to this value. And what you can see here is I'm using placeholders for my bind variables. And then at the time the code is run, it binds in these three parameter values into these three placeholders, and then off we go. So clearly, every time I call this update numeric value, my argument values might change. But as long as my column name hasn't changed from one that was executed before, the physical SQL statement is the same. These different values don't affect the parsing. So that's one of the advantages of binding rather than concatenating. It's also a lot easier to read. Here's an example of that same code with concatenation. So notice I've got start and end dates. Well, dates are a problem. You have to convert them into strings if you're using concatenation. So I do a to-char of my start in with my format right here. And then inside the SQL statement, I need to convert that string, which is, it's a date, but it's a string format, back to being a true date. It's a mess. And you don't want to do this if you can in any way possibly avoid it. And you can usually avoid it. Notice I do have concatenation here because I have a column name and I can't bind a column name. So make sure that you identify and only concatenate when you absolutely need to. And your life and your security will be a lot better. Execute immediate a variable, not an expression. Now, I don't know how much experience all of you have with writing dynamic SQL. I have a fair amount. And what I have found is that learning how to use execute immediate is not that difficult. Using DBMS SQL, the old style dynamic SQL mechanism, is quite complicated and very rarely needed. But the hard part about dynamic SQL is getting the string right, missing a comma, missing a single quote, missing a space between clauses. So many different ways that you can mess things up. If you construct the string inside execute immediate, it's lost. You can't see it when something goes wrong. So you assign it to a variable, execute the variable, and then if something goes wrong, you just log or display the variable in your exception handler. Here's an example. This is a program that I love to show people and scare DBAs, drop whatever. So find all the objects that match name and type with a default of %, everything. So find all those records with a static cursor, and then with a cursor for loop, construct the drop statement, and then drop it. Great. So you can call drop whatever without any parameters, well, except you want to make just checking false, and then it'll drop everything in your schema that it can. Ooh, very dangerous, but it does demonstrate some nice best practices. So here's my drop statement, and what I could do, if I was kind of lazy, is put it right inside execute immediate. There we go. The problem is if something went wrong and I track the exception and want to look at it, I don't have that string anymore. So very simply, always assign it to a variable, execute that variable, and then in your exception handler, you've got the string, you can look at it, and in an instant, you'll see what the problem is. Finally, when you're doing dynamic DDL, executing a create table statement, a create index statement, etc., every time you parse a DDL statement, whether dynamically or statically, Oracle will cause an implicit commit to the executed in your exception. All outstanding changes will be saved. Now, in general, dynamic DDL should be done with great care and usually very rarely in a production application because it can cause a cascading ripple of invalidations of program units. But in any case, if you're doing your dynamic DDL in a stored program unit, you can constrain or limit the effect of the implicit commit by using the autonomous transaction pragma. Back to drop whatever. Here it is. So what this statement says is that any changes I make in this program, any DML changes, must be committed or rolled back before the program terminates. And what that will do then is only commit or roll back these changes inside this program and not in the outer session, which is a great technique, for example, for logging errors. You want to write an error to the log table, commit it, but not commit your transaction. Obviously, there's some sort of problem you're dealing with. In this case, the autonomous transaction will constrain the scope of this implicit commit to this one program and will not cause a ripple effect through the rest of your session. And also just another little tip that I can't get into much more detail on now. When you're doing dynamic SQL, DDL or not, you probably always want to make it auth ID current user, which is what you see here. Auth ID current user simply says that when this program is run from some other schema, not the owner schema, it will run with that current user, the invoker's privileges. So when you try to drop something, you'll try to drop something in the schema owned by the caller of the program, not the owner of the program, which is extremely important when you have a centralized code repository and you grant execute to other schemas to use. Okay, well, let's conclude, and then I've got a couple minutes for questions. So when and how to write SQL, some conclusions. First of all, most importantly, cannot be underestimated or underemphasized. Leverage the SQL language fully. Oracle has spent an enormous amount of its resources to make the Oracle SQL variant the strongest, the most flexible, the most powerful, implementation of SQL on the planet. If you do not utilize it fully, then you are basically devaluing the Oracle database inside your company, and that will cause all sorts of downstream problems, including a less than optimal application. So reserve PLSQL for logical flow, business requirements, etc., that cannot be done in set-oriented SQL, and keep up to date on those enhancements. Second, the most important thing, avoid repetition of SQL statements. We could talk about implicit cursor that, execute, immediate with a variable. Those are all good things to know, and like I said, check out Bryn Llewellyn's white paper. But the most important thing to do is avoid repetition of SQL statements, avoid repetition of any logic in your code. If you don't avoid this, if you repeat all over the place, it's a loss of control in your application. It'll be very hard to optimize your code, maintain your code, and look good with your boss. So if you want to get a promotion, if you want to rise up to senior programmer and emeritus senior distinguished programmer and so on and so forth, encapsulating SQL and encapsulating all sorts of stuff, hiding details behind a named object is the best path to a great career in software. There, how's that for motivation? Finally, set standards for writing SQL in your applications. If you don't have standards, you don't have a chance of applying these new features properly, of making sure they're done consistently, of having an application that is truly maintainable. So I encourage you to put together some sort of set of standards in your application, not only for PLSQL, but for how and when and where to write SQL statements. All right, so thanks for joining me. A few useful websites for PLSQL developers. AskTom.oracle.com is AskTom's great Q&A site. Oracle.com/PLSQL will take you to the landing page for Oracle's resources on PLSQL. Check out PLSQLchallenge.com, which offers an active way of learning. Instead of reading stuff and watching videos, you take quizzes on PLSQL, SQL, database design, logic, and more. It's a great way to really drive home and internalize your knowledge. And hey, compete with others if you want. Oracle-developer.net is a great repository of articles on SQL and PLSQL by Adrian Billington, one of my co-authors. He's a specialist on pipeline table functions. And Oracle-base.com, which is Tim Hall's set of resources and script, a truly outstanding website. I encourage you to check out all these great resources. In terms of my code, it's now based in Oracle. So here's the full URL, but I've also created a shortener here that you can use to go at to get all the different files. And in fact, it has a typo, so let's fix the typo. It's sfdemo. And then let's also give you my blog. And my Twitter handle. Sorry, I'm new at this. I'm just getting my act together here for you. Okay. So this is my blog. This is my Twitter handle. And I'll make sure that my blog also has a link to the code and also the latest PowerPoint and so on from this presentation. Okay, so that's the end of the presentation. What I'd like to do now is switch over to my chat line. And let's see what I've got for chat.